In 4.9b, we are still going to be talking about slope as a rate of change, but this time we are going to look at it with some word problems. In our last section, we looked at graphs and tables, and now we have word problems. So our first piece that we're going to review, when finding a rate of change of any given situation, first write the information as an ordered pair. Remember, an ordered pair is some x comma y value. Then use the slope formula. So that is what we're going to do in our word problems. Find our ordered pairs and then use our slope formula. So number 1 says, in 2001, an iPod cost $400. So our time is always going to be our x. Let's write that on the side. X, always time. So in 2001, that is our first x value. 2001, our iPod is $400. So our other value that is not time, it's going to be our y. So then in 2007, so this is our first point, x2, in our second year, an iPod cost $250. This is our y2. What is the average rate of change in the cost of an iPod per year? So if we have our x1, y1, and x2, y2, we can just plug those in right away to our slope formula. We have 250 minus 400 over 2007 minus 2001. We get a negative 150 over 6. And that simplifies down to negative 25. So if we look at that number, negative 25, we have our dollars on top and our years on the bottom. So this tells me that negative $25, our iPod is going down $25 per year. That is my answer to that question. Our second question, it says that in 1996, so right away, year, that's time, x1, the number of people who visited U.S. theme parks was 78.8 million. Another variable, y1. That goes with my x1, so this is my y1. Then in 2002, so another time period, another point, the number of people was 92.4 million. So that goes with my second x value. What is the rate of change in the number of people who visited the theme parks? So if I plug in my numbers, my slope, 92.4 minus 78.8 over 2002 minus 1996. That gives me 13.6 over 6, which is about 2.27. And remember, that number is million. So if we have 2.27 million, we have the number of people over the year. So that means from 1996 to 2002, the number of people changing or coming to the theme park, it went up about 2.27 million people per year. It's important to be able to get this number, but also interpret what that means. So make sure you're including these units on your answers. Okay, we've got one more on this page, number 3. This one says that after 22 games in 2005, J.D. Drew of the LA Dodgers had 10 runs batted in. So I've got 3 different numbers there. So I'm not sure which one's going to be my x and y's yet. I want to see what other numbers they give me first to compare them to. So I'm going to keep reading. It says after 36 games, he had 15 runs. So if I look, I have games here, and runs here, and runs here. So I know that my x and y are going to be games and runs. Now I just need to figure out which one is which. If I read the rest of the question at the bottom, it says, what is his average rate of change per game? Per game is going to be the bottom of my fraction, my x. So if my game is x, I can go back up. Game is my x. This is going to be my first point. And this is my y1 that goes with it. And this is my x2, y2. So now I'm ready to plug into my formula. Y2, 15 minus 22, not 22, 10, over 36 minus 22. This gives me 5 over 14. And if I type that in and get my decimal, that's about 0.36. And on the top I have runs batted in per game. So that is my answer, that is my rate of change. Alright, we've got a few more questions. We're going to go over number 4. It says, during 1 hour of walking, 1 hour, that is time, that is my x value. You burn about 257 calories. That other number, it's going to be my y1. During a 3-hour walk, so now we have 3 hours, x2, you burn about 771 calories. What is the average calories per hour? So we have our points now. I can plug in my y2, 771, minus y1, 257, over x2, which is 3, minus x1, which is 1. I get 514 over 2. If I simplify that, I get 257 calories per hour. So calories, let's write that in there. Calories per hour. That is the average calorie burn per hour. Okay, this next question, we are going to review the x-intercept, y-intercept, and slope of our line. So if we look at this line, we can see it is crossing our x-axis right at this point right here. So if I want my x-intercept, that is going to be my point. I'm going over 1, 2, and I'm not going up or down at all. So it'll be 2, 0. My y-intercept crosses this y-axis right here. So my y-intercept is going to be down, or left and right 0. So my first point is 0. And then I'm not going left and right, so it's 0. I'm going down 1, 2, 3. So that gives me a negative 3. Now I have 2 points on my line. I could find the slope using my 2 points, my x and y intercept, or I could just count my rise over my run. And that is easier for me, so that's what I'm going to do here. If I start at this point on the left, I go up 1, 2, 3. So my slope is my rise of 3, my run of 1, 2. So there are my x-intercept, y-intercept, and slope. Okay, last question, domain and range. If we look at our domain and range, remember our domain is our x and our range is our y. Now when I have a bunch of points, first thing I want to do is figure out what those points are. I got to figure out all my x values and then all my y values. So that's where I'm going to start. I'm going to start by finding the ordered pairs of all these points. If I start here, I have a -1 to the left, and I'm not going up or down, so that is 0. My second point, I'm going left 1, 2, so that's -2, and I'm going up 1, +1. Over here on this side, I'm going 1, down 1, so that's a +1, -1. And then right 1, up 2, 1, 2. And my last point, I'm going right 2, up and down 0. So now I have a list of all my points. This makes it easy because my domain is all my x values. So if I list those out, my domain is going to be -1, -2, 1, 1, and 2. My range is going to be all of my y values. So that gives me 0, 1, -1, 2, and 0. So I did the first part. Now I have my domain and range. The last part says state whether the graph is a function or not. So remember, in order for it to be a function, we cannot have two of the same x values. If you look, we have 2 1s in our domain. So that means this is not a function.